What if you tried so hard to save the world you knew that you ended up accidentally creating a brand new, totally bizarre one instead? Well, that's pretty much the story of Max Planck. He's the man who, in trying to fix physics, ended up breaking it wide open. It's a wild paradox, right? I mean, how does a guy who was convinced that physics was basically a solved puzzle, a man who was all about tradition, suddenly become the father of its most radical, reality-bending idea? That's exactly what we're going to dive into.
Okay, so to really get what Planck did, we've got to rewind. Let's go back to the end of the 1800s. Physics at the time was in a bit of a pickle. Actually, more than a pickle. It was a full-blown crisis. A puzzle so baffling, they gave it this incredibly dramatic name, the ultraviolet catastrophe.
So here's the problem in a nutshell. Physicists were trying to figure out something called black body radiation. You know, that glow you see from a piece of metal when it gets super hot? Well, their theories were just not working. They had two main laws. One worked great for high-frequency light, but was a total dud for low frequencies. And the other one, it did the exact opposite. It was perfect for low frequencies, but went completely off the rails for high frequencies. I mean, it predicted that things should be radiating infinite energy, which is, impossible. Classical physics was basically at a dead end. It was broken. And so, into this mess steps our hero. But here's the thing. He wasn't some young, rebellious upstart looking to shake things up. Nope. He was the establishment. I mean, just look at this photo of him from 1878. This is Max Planck. He is the poster child for a serious, buttoned-up German professor. This was not a radical. This was a careful, meticulous guy who believed in order, in logic, and he was pretty sure the world of physics was already figured out. It's actually kind of funny. When Planck was just a student, his professor literally told him, hey, don't even bother with physics. Why? Because supposedly all the important stuff had already been discovered. The field was done. And for a good while, Planck actually bought into that. I mean, his entire background just screams tradition. He came from this long line of professors and judges. His whole world was the established order. And his specialty? Thermodynamics, the rock-solid, well-understood laws of heat and energy. He was the ultimate insider, a defender of the old guard through and through. But that pesky ultraviolet catastrophe, it just wouldn't let go. It was this nagging problem that nobody could solve. And it was Planck, Mr. Conservative himself, who became totally obsessed with cracking it. And this obsession would push him to a point of pure intellectual desperation. He tried everything. He threw all the tools of classical thermodynamics, the stuff he knew inside and out, at this problem. And nothing. It just didn't work. Every single approach he tried was a dead end. The real-world data just stubbornly refused to line up with the elegant, established theories. And this quote from him says it all. After just years of banging his head against the wall, he finally hit a breaking point. He was ready to try something that went against everything he believed in. He basically saw it as a mathematical trick, a fudge factor that he hoped he could eventually explain away. He later called it an act of despair. And this is it. This is the moment. On December 14th, 1900, Planck stands up and presents his crazy solution. He suggests that energy, something everyone, and I mean everyone, thought was a smooth, continuous flow like water from a tap, was actually chunky. It could only be released or absorbed in these tiny, discrete little packets. He called them quanta. And the energy of each little packet was determined by this beautifully simple formula, E equals h nu, where that h is a brand new fundamental constant of nature, which we now call the Planck constant. Okay, so to make this radical idea a little easier to picture, he used a great analogy. Think about money. You can have a penny, but you can't have half a penny, right? Money comes in these distinct units. Planck was basically saying energy works the exact same way. It's not a smooth, continuous flow. It's more like a stream of tiny, indivisible coins, the pennies of the atomic world. Now here's the crazy part. Planck just thought he'd found a clever mathematical fix, a temporary patch. He had absolutely no idea that his little act of despair had just kicked open the door to a whole new reality. He had just given birth to quantum mechanics and forever changed how we see the universe. So for a couple of years, Planck's idea just sat there. Most people kind of ignored it. But then in 1905, this young, unknown patent clerk named Albert Einstein takes a look at it and thinks, hey, maybe there's something to this. And he uses the idea of quanta to perfectly explain something called the photoelectric effect. And that's when the revolution really took off. By 1918, the rest of the world had finally caught on, and Planck, the reluctant revolutionary, got the Nobel Prize.
And I love this picture. Here you have the old guard and the new guard together. Planck and Einstein actually became really good friends. It was Planck who was key in getting Einstein a position in Berlin, and apparently they would often get together and play music. It's just such a great image, right? The man who reluctantly cracked open a door to a new universe, and the man who wasn't afraid to charge right through it. This quote from another physicist, Max Born, just sums it all up perfectly. He's saying, Planck was, by his very nature, a conservative guy. He wasn't looking to cause trouble. But his belief in logic, his absolute dedication to making the theory fit the facts, was so powerful that he had no choice but to announce this idea, even though it was the most revolutionary thing physics had ever seen. He followed the truth, even when it completely destroyed his own understanding of the world.
But the story doesn't end there with all this scientific success. Because while Planck's professional life was reaching these incredible heights, his personal life, well, it was marked by a series of almost unimaginable tragedies. The human cost for him was just staggering. His oldest son, Carl, was killed in action during World War I. Then his daughter, Grete, died in childbirth. Just 2 years later, her twin sister, Emma, died in the exact same way. And then his last surviving son, Erwin, was executed in 1945 for being part of the plot to assassinate Hitler. He just endured it all. It's a heartbreaking irony, isn't it? The man who discovered the fundamental constants that govern the entire universe had to stand by and watch as every single constant in his own life was ripped away. You know, during World War II, he did his best to try and protect German science from the Nazi regime, but it was a losing fight. His own home was completely destroyed by an Allied bomb, and all of his life's work, his papers, his records, gone. And after his son Erwin was executed, he said it destroyed his will to live. And that brings us to this last, really powerful quote from Planck himself. It's just such a fascinating thought from a guy who started out as the old guard, became a revolutionary completely by accident, and then lived long enough to see his own weird ideas become the new normal. And it leaves you with this incredible question to think about, right? Is that how science moves forward? Not by convincing the old guard, but by just waiting for them to fade away.